Hello, this is ERH 7771. We're going to go through the process of dynamically balancing an EDF rotor. People are calling it the clock method. It's a lot less technical than the dynamic balancing, but pretty much you want to make sure after you statically balance a rotor, and you can look on YouTube for EDF balancing or rotor balancing. After you statically balance the rotor, you want to put it on the shaft adapter, this piece right here, and make sure there's no vibrations at any RPM, or as much as little vibrations as you can at its run, at your flight RPM. After you get the fan assembled, I'm not going to go through that, just read the instructions per fan. After you get the fan assembled and get the motor shaft adapter placed on the shaft, what you do is you tighten the nut, the shaft adapter nut here, down just enough to where you can hold the rotor with one finger, for instance, and twist the shaft adapter. I don't know if my camera is showing this, but I've marked the shaft adapter here, and I've marked the rotor here. And what I can do, we'll just say the marking on the shaft adapter at the tip and the marking at the shaft adapter, or the rotor at the blade, is 12 o'clock. Use a low power battery, because you're not trying to get this, you're not trying to fly with it, but you're just trying to balance it. And for safety reasons, you don't want to spin it up as much as possible anyway. And also for safety reasons, I just usually use a glove just in case, but again, it's very low power. You start at, we'll call this a 12 o'clock position here. For the blade is at 12 o'clock and the shaft adapter is at 12 o'clock. I'll hook all this up here, get it going the right direction. Okay, got it all hooked up, and you can tell I'm not trying to again spin this up as fast as I can. Now, when I do spin it up, I can feel somewhat a little vibration in my hand here. Plus, if I rub my fingernails on a shroud, I can feel even more vibration. It's very, very high frequency, very tiny vibration. This is a WEMO shroud and a WEMO shaft adapter. Usually these things are already statically balanced pretty good from the factory. So now I just have to find the extreme sweet spot on the rotor. And if you do this, especially with WEMOs, they give a good, high frequency whistle. It sounds very realistic when you're taking off at high power. So here's the 12 o'clock position. I keep the rotor as still as possible just by holding the blade, and I'm not holding it tight so it can break. And then I take the shaft adapter with the somewhat loose nut and twist it to 3 o'clock. Hopefully you can see that the marking on the shaft adapter is now at 3 o'clock, where the rotor blade is at 12 o'clock. So then go ahead and try it again. A little bit more vibration, so I know that's not the spot. Hold the rotor again, go from 3 o'clock to 6 o'clock. Pretty simple. Spin it up again. Even more vibration. So now, here's my marking on the rotor. I hold it at 12 o'clock. I go from 6 o'clock on the shaft adapter to 9 o'clock. So, I mean, basically I'm going 1/4 turn every spin up to find, now that's less there. So to find the sweet spot, I'm going like 1/4 turn. And then, most likely in between 12 o'clock and 9 o'clock, that's where the sweet spot will be. So I go half between 12 o'clock and 9 o'clock. And no vibrations. I can put my fingernails on it. And I wouldn't notice that if it was on, if I couldn't hear the sound or feel the motor run. So now we got the sweet spot on the rotor piece. We tighten the nut down, and here's my Neanderthal approach to it. I usually take wire cutters, something with teeth on it, and put it between the threads. Put the teeth between the threads and tighten the nut down. And torque it down real good. It usually doesn't affect the way if the nut has to be taken off if you put the teeth between the threads, the wire cutter teeth between the threads. And then we have a torque down nut onto the on the rotor, so it we can start with the spinner. Now the spinner here on this the Wemo spinner, again, these are pretty well balanced also. But just for the sake of going through this, I've marked the spinner here with the marker. And we're going to go through the same thing. I'm going to start the spinner marker at 12 o'clock relative to the rotor blade. And I'm going to tighten it down with all my crap here. I had it right in front of me. Just a second, I have to go get another screw. I don't know how to edit all that out, so just be patient with me. I don't know how to edit that out either. Can't overstress. Use Loctite when assembling the fans. Having blades thrown at you, it's not fun. Especially if it's just because the screw vibrates loose or something. Alright, I'm going to go ahead and tighten the screw, somewhat similar to the motor shaft adapter, enough to where you can spin the spinner, but it not be loose. So here I have it at 12 o'clock at 12 o'clock. Run it up here slightly. Feel a little vibration in it. Again, for a Wemo, that's pretty much a lot because these things come balanced from the factory. So I'm going to take the spinner and just twist it to 3 o'clock, just like I did the shaft adapter. Okay, way less vibration there. And then I'm going to twist it to 6 o'clock. Sweet spot. Feel nothing if I rub my fingernails on it. And I feel no low frequency vibrations with my hand, no high frequency vibrations with my fingers. And just do the normal and tighten it down. And there you have a balanced fan. fairly balanced fan. It balanced fan. It reduces the tip whine on the motor. It makes it sound, you know, even one with a high pitch makes it sound really nice inside of some good ducting. I appreciate any comments or on the YouTube thread and any help that could be given. So that's the clock method on balancing an EDF fan. All right.